Okay, so let's have an example. So we have here an equation, a Boolean algebra equation, and we want to simplify this equation using Boolean algebra rules. Now, before we do the simplification, let me show you the logical circuit equivalent of this. This is not yet discussed, but I just want to draw the logical equation equivalent or logical circuit equivalent of this equation so that you will compare later on the simplified equation with its equivalent logical circuit and the difference between that with the original Boolean algebra equation. Okay? So, this equation here, Boolean algebra equation, has this particular logical circuit equivalent. Right? It's your X, Y, and Z. Then you have another equation. X, Y, Z. And then this one here, another AND gate. Now X, Y bar, Z bar, X, Y, Z. And then the last one, you have X, Y, then Z bar. X, Y, Z. And all of these are being all together or added together. That is your A. Okay? So this one here is your logical circuit equivalent of this equation. And remember that this equation here is not yet simplified. This is our original equation. So try to look at the logical circuit equivalent of this particular logical equation. So these are the representation. Okay, or this is the representation of this particular equation. Now, let us simplify the equation and find out the logical circuit equivalent of the simplified equation. Okay, so let me use the other side of the board so that we can compare later. So you have X bar, Y bar, Z bar plus X bar, Y, Z bar plus X, Y bar, Z bar plus X, Y, Z bar is equal to A. Okay? So, if you notice that these two equations here have a common, which is X bar and Z bar, right? So, we make use of rule 14. We factor out. So, you have X bar, Z bar. What is left is Y bar plus Y. And then, this one here, again, the common factor is X, Z bar, right? So what is left is Y bar plus Y is equal to A. And what is this? That is rule number 3. Any variable or variables or no. Rule number 4. A variable added to the complement of that variable is equal to 1. So that means that this one here is equal to 1 and this is also equal to 1. So you have X bar, Z bar times 1 plus X, Z bar is equal times 1 is equal to A. X bar, Z bar times 1 according to our rule number 6. That is equivalent to what? Rule number 6. This is equivalent to X bar, Z bar. Alright? Rule number 6. A variable or variables multiplied by 1 is equal to that variable or variables regardless of whether it is complemented or not complemented. So you have this one, X, Z bar is equal to A. Right? So what is common here? Again, rule. So common is Z bar. So what is left? X bar plus X is equal to A. Right? And this one here, again, rule number what? Rule number 2. Okay? So you have rule number 4, X bar plus X is equal to 1. Right? That is rule number 4. So you have Z bar times 1 is equal to A. And what is this? Rule number what? This one, rule number 6. Any variable or variables multiplied by 1 is equal to that variable or variables, regardless of whether it is complemented or not. That is rule number 6. So you have Z bar is equal to A. So, if you notice that from the original equation, which is this one, it becomes this particular equation using these Boolean algebra rules. Now, if we will obtain the logical circuit equivalent of this will just be this representation. So Z bar is equal to A. So this is your logical circuit equivalent of this equation. If you will compare that with this one here, if you notice that you will be using a lot of logical circuit as compared to this simplified equation. So, the circuit becomes smaller, okay, when it is being simplified using Boolean algebra rules.